Real-time yields analysis. Part 2, accurately tracking yields. A common method. A weight-driven average. There is a percentage of carcass weight assigned to each subprimal. A fudge factor is applied to that number based on the mix of carcasses that went through fab. For example, if more yield grade 2s went to fab, then the expected fab weights will be greater than the standard weight. Inaccuracies. The variations to the basic subprimal percentage for different carcass types can vary by more than 10%. Fabricating various trim specs or variations for a subprimal during a shift obscures which carcasses went into the different versions of that subprimal. Fab example. Shift fabbed 1,000 head of 850-pound carcasses. The loin line fabbed 200 of a 189, 400 of a 189A, and 400 of a 190. Potential outcomes. This table represents the outcomes for the 189, 189A, and the 190. In this first section here, the 189 were fabbed first. The minimum weight there represents the lightest weight that could have happened, having a specific yield grade and carcass type. Probably like the minimum would represent probably a heifer, yield grade 4 or 5, and the maximum weight would be probably like a yield grade 1 steer. And that's the total range of possible outcomes, all using 850-pound heifers, 850-pound carcasses. 400 head for the 189A, same situation. The minimum is 45.95, the maximum is 53.84. That's that's a lot of almost an 800-pound variance that you see there between those two. Again, using 850-pound carcasses, probably the minimum would be probably, again, the yield grade 4 or 5 heifers, and the maximum would be yield grade 1 steers. But even if we were using steers, we'd still see a significant variance between, say, a 1, 2, 3, and 4 yield grades. And again, here we see that same number for 400 head of 190s, again, a number bigger than 800 pounds, significant variance related to the various carcass types. For 1,000 head, we've got a variance of over 2,000 pounds and a dollar variance, because the value of this subprimal, of $37,000. Potential loss value. Okay, here's the range of outcomes that we saw on the previous page. If we don't know when different carcasses types were fabbed, we just don't know what those weights should have been relative to specific subprimals. Even if only 10% of the variance is unexplained, approximately $3,700 per day of potential loss value. That's over $900,000 per year for this one subprimal. This doesn't include variations due to fab inaccuracies, so this is making the assumption that the fab staff completely and accurately fabbed these subprimals exactly the way they should have been fabbed. Accurate yields. What is required? Track the yield grade and sex type of carcass to a carcass ID. So we would know that this is a yield grade 3 steer, or yield grade 2 Holstein, or whatever that might be. That's attached to that carcass as it comes into fab. We're going to track the weight and the carcass ID as it enters into fab, and then we're going to track the item code and the weight of a box as it crosses the box scale leaving fab. We're going to calculate the average weight of the pieces in the box by dividing the box weight less tear by the number of pieces in the box. And then we're going to relate those pieces in the box to the carcasses that cross the fab scale and determine the variance between the actual and the expected yield. Tracking carcasses to box, carcass details. Carcass is entering fab, the carcass ID and weight are extracted for that, and then that data is passed to the server. And the box scale, box crossing the box scale is picked up. The item code and weight for that box, along with the box number, is going to be passed again to the server. And then there's a process of synchronization that takes place, linking the carcass ID and weight to the item code and weight of the box. Tracking carcass to box, synchronization. We assume that the subprimals crossing box scale are directly related to the carcasses in the order they cross the fab scale. If a box contains 6 pieces, then we assume that these pieces are related to the 6 sides that cross the fab scale at that point in the fab order. Carcass sides don't have to be sequential, as each side is read separately. And if pieces in boxes are out of sequence, moving total of these sides can still reflect an accurate analysis of yields, and a cumulative total will correctly reflect the yields. Potential loss value with accurate subprimal tracking. Without subprimal carcass tracking, that's the table we saw previously, but when we track the actual subprimals, knowing which carcasses they came from, that potential variance, at least in terms of the actual expectation in terms of yield, goes to 0. We eliminated the risk associated with not knowing which carcasses were fab for each subprimal. Real-time yields analysis. The next video will be part 3, accurately calculating yield variances.